Hey everyone, hope you're doing okay today. All right, so in this video, we're going to be going over cylinders, right? Which is a topic that you probably did a week or two of in ninth or 10th grade when you did geometry. Maybe you did a bit in middle school and elementary school, but it's not something that comes up too much in your day-to-day high school math life. But it does come up a fair amount in the SAT. So we'll go over how to solve these types of questions, the formulas you need to know. These formulas are on the reference sheet, right? So if you forget them, you have them. But it really helps to have them memorized just so that you don't have to go back and look at them and just to save you time and be more efficient with your time, especially because on the second math section of SAT, time is really pressed. So there's two equations you need to know. There's volume, which is equal to, right, so a cylinder, we look at it. Excuse my terrible drawing, but I'll get the general idea, all right? There's two main parts to a cylinder, two main dimensions. There's the radius, right, like any circle has, and then there's the height, which is the distance between the two bases. So volume is going to be the area of the base times the height, which is the same for any, right prism. So it's going to be pi r squared, which is the area of the circle, times height, and then you have surface area, which is going to be the area of the two circles combined. So that's going to be 2 pi r squared plus the circumference of the circle, right? Because that's a little loop that determines how wide. And then you have the height. So it's going to be 2 pi r, which is circumference, times height. Okay. So with these two formulas, you should be able to solve most any type of cylinder question that the SAT might throw at you. It just becomes about knowing when to use them and how to use them efficiently. So let's look at this question, right? Volume of a right cylinder is 432 pi cubic inches and its height is twice the length of the radius. What is the radius of the cylinder in inches? Okay, great. So we're going to use volume, right? So we'll do 432 pi equals pi r squared h, and it told us h equals 2r. So we'll plug that in. So 432 pi equals pi r squared times 2r. So that equals 2 pi r cubed. So you have 432 pi. Then let's divide by 2 pi. And then you're going to get 216 equals r cubed. And you can put that in the calculator and find it. You could also do it hopefully mentally and know that r equals 6, which is my favorite number. One day we'll go over why that is. But so that's all you did, right? You just did volume. You didn't have to do surface area, which is nice. Surface area is a little bit uglier. And then let's go on to the next question. Cylinder A has a volume 6 times the volume of cylinder B. A surface area that's 10/3 time the area of cylinder B, and a radius that is double the radius of cylinder B. If cylinder B has a radius of 1 inch and a height of 2 inches, what is cylinder A's height? Okay, so this question is not just testing your ability, your knowledge of cylinders and their formulas, but also your ability to process information. Some of these questions on the digital SAT are about, can you read the question well? And can you process the information and know which information is relevant and which information isn't, right? And it feels like you're a long way from the question with all these little numbers, but you want to start with what feels easiest. So for me, the easiest thing is to find the volume and the surface area of cylinder B and see where that helps me, right? So volume of B equals pi r is 1 squared times height. And that gets me 2 pi. Okay. So that means volume of A equals pi. So the radius, right, is double the radius. So r of A equals 2. And then volume of A is going to be 6 times 2 pi. So that equals 12 pi. And we're looking for H. So we should be able to find it now, right? So we have 12 pi equals pi 2 squared H. Then we can divide out the pi's. We get 12 equals 4H. H equals 3. And as you can see, right, we never even had to use 10/3 times the area of cylinder B. But just for, you know, thoroughness sake, let's see what we did if you want to do surface area instead of volume, right? So let's do surface area of B. Equals 2 pi 1 squared plus 2 pi 1 times 2. And that's me 2 pi plus 4 pi, 6 pi, right? So that's surface area of B. And then we're told surface area of A is 10/3 that. So surface area of A equals 10/3 times 6 pi, which equals 20 pi. Okay, great. And then when we have 20 pi, we can plug that in. So then we could do 20 pi equals 2 pi r, which we know is 4. So it's going to be, or 2. So it's going to be 2 pi 2 squared plus 2 pi 2h. Then that gets us 20 pi equals 4 times 2 is 8 pi plus 4 pi h. We'll get 12 pi equals 4 pi h. And again, we get h equals 3. But as you see, all this stuff, right, from here down, we didn't need to do. It was just to show again that it's 3. But you did this just with volume and you can find the answer. That's great. And that's just testing, which information do you use to process and which one can you cancel out? And can you do it without being overwhelmed by all the information they're giving us, right? So this was important, this was important, that was important, this was important, and this was important. All right, so then last one for today. Cylinder A has a height that is 3 times the radius, r. If you multiply the height by 9, and the new volume is 4 times the original volume, what is the new radius in terms of r? Okay, so again, processing information. Height by 9, new volume is 4. 3 times the radius r, but our answer is in r, so we don't actually need to solve for what h and r are, so that's probably not helpful, especially because the height is going to be changing from one to the next. So let's say the first volume, right, v equals pi r squared h, right? And then the new volume is going to be 4v equals pi x, let's call it x, x equals new radius x squared 9h, right? So then we're gonna multiply this one by 4 and set it here. So then it's going to be 4 pi r squared h equals pi x squared 9h. And then let's divide by 9h pi. The pi's cancel. The h's cancel. And then we're just left with 4 ninths r squared equals x squared. And now let's do square root, right, to get x. So when you square root, you're going to get x equals square root of r squared is going to give you r. Square root of 4 ninths. Square root of 4 equals 2. Here, let me make that blue just to show it's a different type of step. So we're going to get 2/3 r. So the new radius x is 2/3 the old radius, which is a. Right. If you look at the answer choices, you could say that it wouldn't be D, just based off of if you're multiplying the height by 9, but the volume isn't going up by 9, that means the radius is shrinking. And it wouldn't be C because the radius is shrinking. So then you're down between A and B, and working it out from there gets you that it's A. Okay. So again, 3 times the radius didn't matter. Just like here, the 10/3 didn't matter if you just did volume. And here everything mattered, but there wasn't that much information. And we will continue with more geometry in the future. We'll probably return to cylinders. There's questions that are less theoretical, in which the cylinder is a can, and then you have different sized cans, and you have to see how many little cans fit in the big can, and so on. But that's all for the future. And again, if you have any questions or comments or any material you'd like to see covered, let me know. I'd be happy to do that. And like and subscribe to keep getting more content like this. And it's a big help for growing the community. And I'll see you all next time. Thanks.